Hello friends, I am Sudhanshu Bhargava. My final project for HUE E63 classes Analytics classes Flume, a distributed system for collecting streaming data. Uh, Data analysis is only half the battle. Getting the data into Hadoop cluster is the first step in any big data deployment. Apache Flume, as the name suggests, is used to transfer streaming data from one source to another using channels. It is distributed, reliable, and available system for effectively collecting, aggregating, and moving large amounts of primarily log data from many different sources to a centralized data store, which can be HDFS file system or local directory and even HBase. Begin my presentation by providing a brief description of Flume and its core concept. Then I'll move on and show you and describe how Flume works. Then I'll describe what are the steps that are needed for a successful Flume deployment, and then I'll provide a brief demonstration of the project I did to explain the functionality of Flume. What is Flume? Flume is collection aggregation of streaming event data, typically stored is used for log data, is used commonly to get weblog data to HDFS. Okay, let us discuss the architecture of Flume. Uh, Flume is a distributed, reliable, and available service used to collect, aggregate, and move large amounts of streaming event data from many sources to a central data store. So this diagram represents a typical Flume implementation. So the external data that you see is the Flume has three main components: the event, the client, and the agent. A Flume event is defined as a unit of data flow having payload and an optional set of string attributes. The Flume client is the entity which generates the Flume data event. The Flume agent, the Flume agent that's represented by the rectangle here is a typical JVM process that hosts the component through which the event flows from an external source to the next destination or an external repository. Again, an event is the main unit of data transferred from source like log data to the destination sink. Event is a byte array payload accompanied by optional headers. Payload is opaque to Flume. Headers are specified as an unordered collection of string key value pairs with keys being unique across the collection. An entity that generates the event and send it to the agent is a client, for example, Flume log4j appender. It decouples Flume from the system where event is generated. A Flume agent could contain three main components like sources, channel, sink, and depending on how it's implemented, there could be it could have further elements like the interceptor or the sink processor. The agent is the fundamental part of Flume flow and it provides configuration, lifecycle management, monitoring support for hosted components. Let me move on to describe what a Flume agent has three main components: source, channel, and sink. The source consumes events delivered to it by an external source like web service. The external source sends these events to Flume in a recognizable format. When a Flume source receives event, it stores them into one or more channels. A source requires at least one channel to function. A source could be of various time, namely specialized sources for integrating with well-known systems. For example, syslog, netcat, and auto-generating sources like exec and sequence. IPC sources for agent-to-agent communicator like AVRO, Thrift, and a channel is a passive store that keeps an event until it is consumed by a Flume sink. For example, a file channel uses a local file system. The sink extracts the event from the channel and puts it on an external repository like the HDFS or towards it forwarded to a Flume source as a new next Flume agent or next hop as a flow. The source of sink within gave a sink could be of multiple types and they include terminal sinks that deposited events to their final destination, for example HDFS, HBase, Auto-consuming sync, example null sync. IPC agent for IPC sync for agent-to-agent communication, like AVRO thrift. AVRO or Apache AVRO is a very powerful sync or source that is used by an AVRO source from half of Flume's tiered collection support. Internally, this source uses AVRO's netty transceiver to listen for and handle events. It can be paired with the built-in AVRO sync to create tiered collection topologies. Other popular network streams that Flume uses are Thrift, Syslog, and Netcat. Apache AVRO is a data serialization format. It's an RPC-based framework used widely by Apache projects such as Flume and Hadoop for data storage and communication. Moving onward, this particular slide demonstrates how the source and the channel work together. An external entity or the event sends the data in batches to the source. The source typically creates a transaction batch in which it collects a series of events, and once it has collected sufficient number of events, it will start the process called begin transaction to transfer all these events to channel, and then it will transfer all this. It will drain out all the events from the source to the channel, and it will commit the transaction in order to maintain reliability. The same process is repeated between the channel and the sync until the all the events are drained from the channel to the sync, and the sync further performs the similar action by sending all the events to the external data stores or the final destination. There are multiple implementation of Flume is available right now. The most common one is from the Apache. The latest stable version 1.40. It can be downloaded from flume.apache.org/download.html. The Cloudera has also implemented its own version of Flume. There's a bunch of other companies that implemented it. The most um, there's only one main prerequisite for Flume is required, and that is it should have JDK 1.6 or higher installed and a Java home defined for it. Flume works out of a Java properties file in which it defines the agent sources and channels. This slide shows a typical properties file used by a typical Flume implementation. Like in this file, the first lines define the source sync and channel. Like A1 is the agent name and source, and it assigns source of R2 to A1, and then it defines that A2 would be using the sync K1, and A1 the channel for A1 is C1, and then going down it defines what would be the agent type would be. Like the agent type R1, the netcat type, which is going to bind on port 0000, which is localhost, and it will be listening on port 4444. There could be multiple sources defined for one agent in the same file. Similarly, multiple things could be defined for one agent. Here I am defining two agents, two sources for the same agent A1. One is an exact source which is identified by our name R2, and then it defines the type and the command. Each agent will name at least one type and one channel to work. The bottom portion of this file defines the sync. What is the type of the sync? So it defines K1 sync, which is of HDFS type, and then the path for the writing the data would be /tmp, and then the format for the data would be text, and the data would be coming in as data stream type, file type. So to improve the overall performance of this implementation. So once you use Flume, this is how Flume typically stores. Flume will create multiple files based on the data that's transferred between source and the sync. So it will create multiple files with the name Flume data, and then it will and then it will suffix with a number to indicate a different file. This diagram typically represents a multi-tiered or multi-hop implementation of Flume. In this there are two agents that are testing for the same set of data. The top and the bottom rectangle. It is sending the data over a channel to an AVRO sync. The AVRO sync you is sending the data to the AVRO source of the middle agent, that let me call it collector. The collector will get the data from the sync of both the agent sources, and then over the channel it will send the data towards the HDFS sync. The HDFS sync will then transfer the data and write it to an HDFS file system, which is represented by the external cloud here. Okay, this is how a typical implementation of Flume works. Next, let me provide you with a brief demonstration of my project to make you better understand how Flume works. Okay, let's begin the demo by looking at the configuration file used for agent and the source. So here on this thing, what I've set up is the agent configuration. So in this case, you can see that I've defined the agent as sources as exact, and the command to execute for is the agent sources tail minus f slash var slash log slash flumeng source dot text. Now this command will tell the agent sources when it started that you have to go check the contents of the file named source.txt, and then get whatever is the update to that source file, and put it on on a channel called memory channel, which is defined later. And then the sync to use is what I call is AVRO forward sync. The AVRO forward sync is defined with the type of AVRO, and the host name is the local host I'm using, and then the port that I'm using an arbitrary port to connect it, because I need to define this as a source to the collector. So that's why the port I'm using is 60,000. These are various other properties like the channel capacity and channel transaction capacity that I've defined at some high number. And then the channel type is the memory channel type is the memory. Let's move on to collector configuration, which is essentially the source is the same as the sync for the agent configuration. The source is AVRO collection source, which is defined as a type of AVRO source which is bound on the port 60,000 for IP address of localhost. And then the sync for this collector is essentially the HDFS file system. The path to the file system is slash tmp, and the write format would be the text. This is how the setup is. Channel capacity is the same. So starting the agent on both of the system. So I started one here and I started one on the other window. Eventually I should be looking for both of them as started. So let's give it few more minutes. Now as you can see from the text that was scrolling in both the windows, that the sync has been started, and the source and sync has been started, and it's kind of listening for event to data to move through each one of them. Let us run the I've created a jar file for a list to getting all the RSS feed from bbc.co.uk, and write it to a file called source.txt under slash var slash log. So let's first examine the contents of my Hadoop file system under slash tmp. Uh, so under Hadoop, there's only one Flume file that was written because of some data transfer between the two. Let me just run this. Let me just run the Java program using Java minus jar. And as soon as I run the program, you can see the activity happening on both ends. You can see the about 100 suddenly it started polling for, it started writing the data, and the data is being transferred to HDFS sync from so this is the left window is getting the data and transferring the data to the right window, which is writing the data to the sync. uh, Let us give us few more minutes to finish, few more seconds to finish. Okay, moving on. Looks like this is finished writing. Let's stop one of, but just interrupt one of this. So when we stop this collector, you can see that, and let's do a lookup on temp. It created a bunch of files. Let's look at the content of any one of them. Let's pick this one in the middle and see what do we have here. It's some sort of news regarding a bit of a news fragment which was generated on today's date of Sunday, May 11th, from the BBC. So essentially, what the news was returned to the source.txt, it getting through to the Hadoop file system. So that proves that Hadoop is a very good system for transferring streaming data from source to HDFS system.